Hello, welcome everyone. My name is Brendan, and today I'm going to talk to you about Java. I mean C#. So first off, you may have noticed the title. It is not your mother or father's C#. That's what we're going to talk about. It's not Java. I was kidding. Obviously, my name is Brendan. I toss links to stuff that can be found on the internet. If you are so inclined, feel free to visit me at any of those. I'll have them at the end, so feel free to ignore it now. Before we get started, I have a disclaimer to get through. First off, my father never used C#. That was a lie in the title. He did use PHP. I am a second-generation programmer. My mother also did not use C#. So, as you can probably guess, everything is, in fact, a lie here. There will be nothing true. And you might now be wondering, is my name even Brendan? And the answer is no. I am, in fact, a middle namer. My name is not Brendan. My parents did not use C#. OK, let's jump into some more lies. So these ones will be lies that people tell themselves or think about C#. The first one I want to talk about is that C# is a Visual Studio only, Windows only language. And the answer to that is, well, it was. But now we have tons of places where we can write it. And yes, I am going to start with some of these slow things for anybody that is not familiar with the C# world. It no longer is that. It is now able to be written on Windows, on Linux, on Mac, using a variety of different IDEs. There are a bunch of people that think C#, that's that language you use if you're writing for Windows. And the answer is no. You can also use C# to do all kinds of stuff on different platforms. You can write video games with it. You can make the standard business applications. Tons of different stuff is usable with C# now. A lot of people that use web development, I'm assuming a lot of people here do web development of some kind? Yeah, that's a large number of people in the room. Does anyone here host C# apps on IIS still? Yeah, sadly, I have a few clients that are still on it. We don't have to do that anymore. We now have more modern cross-platform, lightweight platforms for that, like Kestrel. One of the other big things that most people think about C# is that it is one of these curly brace languages, where the entire thing is just going to be curly braces all going down the line and then back over again, and everything's curly braces. Well, that is, OK, still a little bit true, but hopefully less true, thanks to some of these changes that we'll talk about. So the last few versions of C# have made significant efforts towards reducing the number of curly braces that you have to write in. So you might have had code that did one of these big triangles in your code. And yeah, everybody here's seen this stuff? Your code? It looks great, doesn't it? Does your code look like this? Anybody? Yeah, it's awesome. So this code does a whole bunch of stuff. Obviously, this is like an old style using like old data connections that we don't really use in C# that often anymore. But newer versions, you can get down to this, where you can technically get even smaller than this. I didn't go completely crazy, but you can really reduce the amount of indentation, the amount of curly braces in current versions of C#. Now, I made a joke at the beginning of this, pretending that I'd forgotten that C# talk was actually a Java talk, like that kind of thing. C# was a lot like Java in the early 2000s. It was very, very similar. Now, they are both the same type of language, but they have deviated a significant amount. One of the last things I want to mention here is that most of us think of C# being like, yes, you build this big monolithic app thing, and it is not really the case anymore because we can now break it up and you can deploy it on containers and build your small little applications using C#, which is a really nice thing to have a lighter weight C# than we had before. So let's talk about old C#. This is your mother or father's C#. Now, back in the day, it really was missing some of the basic stuff. Trust me, I used it back then and was horrified by some of the things it's missing. What? What would it be missing? What kinds of things? Well, in the past, we didn't have generic types. That's going way long ago, but they added those. And we got really nice generic types. We got a decent implementation that has continued to be a good one. You may have also noticed I came from Python before I switched to C#, so I was very disappointed when I no longer had Lambda functions. And these have significantly changed the language. And C# now has fantastic, strongly typed functions. And you've got various ways of declaring all of these functions. So there's tons of stuff that you can do now in the language that you couldn't before. Did anyone here ever use the old tuple type, or tuple type if you prefer, in like the system tuple that was existed? That thing should never have been used by anyone. It literally only lets you create an object that had item 1, item 2 as the values in it, etc. You could not name them. It was just a type that you used. It was pretty much a joke. But now we have, 6 years ago-ish, I think, we got a really good tuple implementation that, well, okay. That's not fair. I'm kind of lying here. 6 years ago, we got a decent implementation that was missing a handful of features, and they got added in after the fact. And the nice thing is that each new version has improved on it, which has been really nice. And then one of the other recent additions, 8 years ago, 9 years ago, something like that, we picked up async and await. And the cool part is that pretty much every other language implemented basically the same thing, basically the same way. So you may have noticed that a whole bunch of languages grabbed this at the same time, and some of that is because the different languages pulled their syntax and implementation from the same language, and some it was inherited in other ways. But a lot of languages got their idea from the same sources. Now, one last thing I want to talk about before we start diving into what the fundamental changes actually were is this. Versioning, and especially version numbers and names at Microsoft, are perfect, have never confused anyone, and are very clear. That's what I have to say about that. The versioning on C# has been a little weird even. So let's talk about what it was before, because I need to cover this so that I can talk to you about what features exist while telling you which versions you need to be running in order to use them. So back in the day, we used to get fairly inconsistent releases of C#. And you'll notice that at one point, it got a little bit weird, because they released C# 5, and then 6, and then 7, and then they said, you know what, we want to do these little releases that only put out a few things. And so then they did 7.1, 7.2, and 7.3. And you kind of go like, okay, now you're confusing everybody because they don't know what versions you're on because you're getting into all of these complicated versions. And thankfully, they have stopped doing that. The new way is annual releases. And what I like about that, I should clarify, I didn't mention this at the beginning, I don't work at Microsoft. I am independent and no association. So they do annual releases. Their versions are tied now to .NET versions. So you used to pick which language version you wanted and which framework version now. Now they just say, okay, if you're using .NET 5, you're on C# 9. If you're using .NET 6, you're on C# 10, etc. And so that makes it a lot nicer. The last thing I want to talk to you about before we jump into stuff is this. The versions that you choose should be based on either features that you need or the lifetime. So with even-numbered versions, those come with long-term support and are 3 years of support, and it is 1.5 years if you're on an odd number. So the current version of C# is, and I should say, man, I messed this up on the slide. I really should have written it this way. This is odd and even versions of .NET, which is going to be tied to your language. So right now, .NET 7 is the current version, and .NET 7 will end its support before .NET 6. So that's why I say only upgrade to an odd-numbered version if you actually need its features. That being said, as you can all tell based on what I've said already, C# is now, in fact, a young, cool, and hip language, not the outdated old language. So I'm sure I've convinced all of you that this is not, an old person language. All right, so let's jump into what has changed about C#. So the null reference, that's clearly gone. We don't have that crap. No, never mind. These are still here. They're trying to get rid of them, and one of the big changes that you'll find in most of the recent versions of C#, they have done something to do with nulls and handling nulls, and they are still working on making new changes to this. Not that this has been the problem plaguing this style of language for decades. This is when you all get upset at me for having your PTSD trigger from that. Okay, so avoiding null references. I do want to talk about this handful of stuff just in case people haven't seen it. If you are from one of the, if you haven't touched C# in a while, we added all the fun stuff, null coalescing operators, for example. So A, question mark, question mark, question mark, B, and we just say, hey, if the left is null, use B, use the right. And it works like this. If you have null conditionals, you can say, hey, if the value on the left is null, just propagate that null and make B null also. You know what the problem with this is? We can still get null references off of this because now you're returning back a null. Okay, so that's null propagation. It lets us take code that was written like this before, where we said, hey, if it's null, do this, if it's not, do that, and we can now write it like this, which is nice. And I mentioned that that bottom value there, the nickname, if that ends up being null because the user was null, well, then you should probably combine it with a null coalescing operator and do that. The one trap that you can run into that I do want to make sure I mention is that this is also a way of writing that. You'll notice that you can either do question mark dot or you can do question mark into square braces. And does anyone in the audience know what this will not protect you against? Did someone say null reference? No, it won't protect you from that. But it could, you could run into a problem that if that is an empty collection, you still can hit an index out of range. So we didn't catch that one. So the last one, and this is the most recently added one, and personally my favorite of this, because null propagation can still lead to null reference exceptions, is the null coalescing assignment. That is the, hey, if my object is null, go ahead and assign it this value, which is great because this gets rid of the null. So if you can't remove nulls entirely, this helps keep you safe. It's a, if someone forgot to initialize this, please initialize it. So that would look something like this. Oh, I didn't fix that slide. Yeah, we'll pretend that that parenthesis and semicolon's on the same line there. And if you'd looked at one of these, you might see that if we set n initially to null, we can then assign it the value of 42. And then after that, it does not get assigned 1337 and prints out 42 because it already has a value. So the last thing, and this is the important one, who here has nulls turned off in your code base? Anybody in C#? I do. I do this. So there is something now called a null annotation context. And this, a lot of people refer to as nullable reference types, which is the worst way to describe this feature. This got added to the language a few years ago, and it got called this, but nullable reference types is what we had before. They were the nullable values. But now we've added the feature that you can tell the system, hey, I'm going to use nulls, or no, I'm not going to use them. And the way they implemented this is by making it, making the compiler essentially check to be sure that you have always initialized the value. So it tries to watch you and say, hey, you didn't initialize that, I'm throwing an error. Or this could be null here, you need to handle that. And it's really nice. And it's not confusing at all and not annoying. Right. So the way that you do that is There are a couple of ways, but the best one to do it is to just enable it at the project level. So also, if you're being annoyed by this in C# and you want nulls, just get rid of this, and you'll be able to switch back. You can also do this for individual files, though I don't recommend it. But you can put these prefixes in place to essentially disable nullable values within that context. Okay, so that's the main stuff they did to handle null reference exceptions. They're working on a few more things. We'll see what happens. The next thing I want to talk to you about is getting rid of all of the clutter. So let's talk about a few. Who here has recently created a C# project? Anybody? All right. Who here forgot to check the checkbox telling it you did not want top-level statements? Yeah, I've done that. So top-level statements is an interesting new feature that I kind of want to warn you about. In C# now, you don't have to have your code inside of a class. So you can literally just write code in a C# file and have that be your code, and you can run it. So your program CS, you can just start writing code, just like this. And you don't need to have, your program, your main, like those stuff, they don't have to be there. There's no curly braces in here. And you're like, wow, that's awesome. But why would I want that? And the answer is demo apps. That's about it. So like, if you're standing up on stage, you need a demo app and you want it to be super short, yeah, this feature was for you. The other one is if you are a beginner and you're just learning C# and how to program with it, and the idea of creating classes for everything is confusing, and there's a whole bunch of extra stuff that you have to do in order to get your code running, you don't have to anymore. So they put that in there. It's kind of nice, but I wouldn't recommend using it very often because having one file that works differently from the rest of your code base is weird. I don't know, that's just me. All right, so this next one, oh, typo. Static unings, see that? Pro tip, everyone, always edit your slides the day of your presentation. It makes you look professional. So this is actually in here, not because it's a recent feature, because it's funny. Static usings are actually a really cool feature that lets you say, within this file, this static type is just treated like global almost. So instead of having to say console.writeLine, by using this code, I can just say WriteLine. And you're like, but why? And the answer is demo apps. See, so if you need to do presentations, C# has you covered. You don't have to have classes. You don't even have to call console. You can just say WriteLine. Looks super nice. Okay, the last thing I talked to you about curly braces. Let's see how we can get rid of some, because I think I'm the only one in this room that loves curly braces. Yes, thank you. Yes, curly braces are the best. I'm glad someone else loves them. So, using statements. I talked about static usings. That's where you put it at the top of the file and you say, hey, I want to use that static class. The other kind of using is where you say, hey, I want to include this namespace inside of this file. The third use of the word using, remember what I said before about Microsoft being fantastic at naming? Yep, here it is again. So the third time that you might use using is for declaring an iDisposable values context. So that's saying, I want this object to get created, and at the end of this context, I want it deleted. Those look like this. And you do a using statement. It's some kind of object that needs disposing. In this case, we're talking about a file stream. You wouldn't want to leave that connection open. So this will make sure at the end of the context, so at the ending curly brace, it automatically disposes and gets rid of your object, assuming someone created the iDisposable interface correctly. But that also meant that we got extra curly braces. So they instead created something called a using declaration instead of a using statement. So here's your fourth part of a using. And this one just says, hey, the context I'm already in is the lifetime of this object. And so this is one of the best ways to just remove one of the curly braces, one of the sets of curly braces and the indentation. Okay, the next one, and I am actually a big fan of this one, is file scoped namespaces. Has anyone in this room ever declared more than one namespace in the same file? You're a monster. I can't believe you would do that. No, so I don't know of anybody that's legitimately done that. That's a plant in the audience that I have there to help me right there. We always did one namespace for the file, and it'd be weird not to. Like, you might put multiple classes in the same file, but it's always the same namespace. And so they decided, you know what? We'll just let you, instead of doing this, get rid of the set of curly braces and just declare the namespace for the file by putting a semicolon at the end instead of a pair of curly braces, and now that entire file is one namespace. Yay! We removed a layer of indentation, and it's much better. Okay, so every single file you've got can lose a layer of indentation. You're welcome. Go do that now. This next one is one that I am a huge fan of, and I'm going to show you my real code. This is embarrassing, okay? Don't get mad at me. This is what my code looked like. It was my own fault. So I had a class that had this at the top of the file. That's like 2 or 3 usings, right? Declared a couple of namespaces that I imported. How many is that? Like, I don't know, like more than 10, right? Anybody here ever written more than 10 usings at the top of your file? Anybody admit to that? Good. I'm hoping to see every hand. Yeah, we all have. Okay. Anybody here have in your code base anywhere a specific namespace that gets included in basically every file? Yeah. How about system or system collections generic? Do those get used a lot? Yep. And you might also have some other stuff for basic domain objects and models that are inside of your code. And that's what this is for. So you can just remove all the common namespaces right out of your project. And the way that these work is you make a global CS file and just put your usings in there. And the language will now read that and automatically just apply that to your files. So it's just in namespace without you having to do anything extra. So if we get rid of the common ones, like the system ones, you can just remove those from the list, get a little bit shorter. You can then remove all the ones that are common through your application where most of your files use them. And it doesn't even have to be everyone, right? You might be including a namespace you're not using then because it was a global one. But if they're super common and you don't have collisions, anybody here use the same class names in your code base in 2 different namespaces? Well, okay, we do sometimes, but hopefully not often. Don't put those in the global context, please, or you will regret it. You can then start removing more, and guess what? This is how many namespaces I actually need once I've removed all the common ones and the ones that are in almost every spot. So it gets a lot shorter, and this is a great way to clean up your usings at the top of the file. Now, there is a danger here. Does anybody know the danger with this? No guesses? Well, sure. So they get loaded at the same time as they would here. They're treated basically the same. The danger I would warn you about is when you notice that you have like 15, 20 usings at the top of a file, what's your instinct about that file? It does too much. And when it looks like this, I got a secret for you. I didn't reduce how much it's doing. It just doesn't look as bad. So there is a little bit of that. So you do need to be careful that you don't go way overboard and remove too many namespaces to the point where you can't tell which files do too much stuff, but there is that. Okay, let's talk about some stuff that is more, that I don't have good categories for. So that was removing clutter. One of my favorite features that got added is another one of those ones that had been missing in C# the whole time that I was unhappy about, is this, reverse indexing. So does anybody here ever try to grab like the last item in a collection? Yeah, we all do. Well, they added like .last for that long time ago through link. But I'd rather be able to get more than just the last item, maybe the last few items or some set in the middle. And they finally let us do that, and they implemented it with the hat operator, which is just a caret before a number. And I think the reason they did this is because they were probably just looking at the number and they didn't want to use negatives. So a lot of languages use negatives, but I'm assuming that they wanted to be able to tell that it wasn't a negative number and do this. So essentially, if you don't know, you can now in C# just use, instead of a zero-based indexed, you can use essentially negative indexes. You just use the caret operator, and caret 1 is the last item. The other thing they added, which is super nice, is range indexing. And with range indexing, you just kind of say the starting number, and then ... and then the ending number. So if you leave off the first or the last number, you're starting at the beginning of the collection or the ending of the collection. So I've got a handful of examples of how that works up here. And you'll notice at the bottom that you can do ranges with the reverse indexing as well. So this is super nice if you're ever trying to, substring or anything like that. Much nicer than that format. Okay. Now, one other thing that I want to talk about, because this is one of my favorite improvements recently, is memory and span. Who here is familiar with the memory or span types? Handful of people? Okay. So for everybody else, you're probably wondering what this is. And, oh, wait. Sorry, I'm not supposed to talk about this. That's .NET, not C#. There actually wasn't a language change to include this. So I shouldn't technically be talking to you about this, but memory and span are so important to the language and what's changing about it that I'm going to talk about it anyway. So in order to explain memory and span, I want to talk to you about pointers, and specifically pointers to arrays in this case. Now, it doesn't have to be arrays, it can be other collections, but generally speaking, we're talking about sequences of values. So if I declared that, which that looks readable up there, wasn't sure how that font size would be, then what it really creates is a sequence of objects that roughly would look like this. So there is an array of characters. And if I wanted to get the middle part, and I just said, hey, let me substring that, we'll grab values 2 through 7, we would get a new data set that looked like this. And I now have 2 collections. So I've got the collection in blue and the collection in green. And that's what happens when I substring out a piece. Okay, with memory and span, it's going to work a little bit differently. These are new types that exist in .NET, not in C#. Essentially what happens is, I like to describe it as a window, and we're looking at a subset of some kind of a collection. So you're taking a range that could start at the beginning, the end, somewhere in the middle, and you're just going to say, I want to look at just this piece. Please don't make me a copy. Let me look just at that. And so to kind of illustrate it, this would be the equivalent of substringing out just that center piece, but using memory or span. I wanted to explain that in here just because if you know that that's a new thing in C#, I kind of want to explain what is going on with that, and that's what it is. It's that piece. Now, why is it critically important that I talk about this in a C# talk, even though that's .NET? Has anyone here heard that there have been significant performance improvements in different parts of .NET in recent years? Anybody? Hey, this is one of the reasons why their performance improved, because they started doing this under the hood for some of your operations. So they're no longer duplicating objects in some places where they could avoid it. So a lot of the language changes that you're going to notice, a lot of the framework changes that you're going to notice in recent years, every time they release a new version, there's stuff that you go, why do I need that? And a lot of times the answer is, it wasn't built for us. It was built for the team to be able to improve their own code internally. So a lot of those little fiddly bits are for them. Okay, so next thing I wanted to talk to you about is interpolated constants. So I think I removed everything talking about interpolated strings. Are people generally familiar with interpolated strings in C#? Most people? So interpolated is a fancy word that just means like insert into. So it's, in case someone doesn't, it's a string where you insert in a value. They've now added the ability for us to have constants that were created through interpolation, which we were not allowed to do before. There are a couple of restrictions. So when you are creating one of these, you do have to create them with values that are present at the time that it's going to be created. So you can use other constants, or you can use values that you have written literally into the code. So you can't grab a variable from a user and create a constant from it. It does have to be a constant value that it puts in there, but you can create a constant from an interpolated string now. Some instances where you might do something like this would, obviously you're not going to do that with a name, but you might do it with something like, oh yeah, our code creates this like domain piece, and so you put the little bits in and separate it out, right? It's constant. And you might even leave this as a format string if you wanted to be used somewhere else. The next thing is new lines in string interpolation, which probably now has someone sitting there thinking, wait, we didn't have that already? And the answer is no. We did not really have it before. So now if you want to, inside of the interpolation, split it up, I first off don't recommend putting complex logic into your string interpolation. So I don't recommend writing the code on the bottom. However, you can. If your code was that complicated, like the stuff on the top, then you probably want to fix it anyway. But if you can't for some reason, now at least you can move it to new lines as needed when you want to. The other thing that they changed about strings is they made a new string literal. So are people here familiar with the @ sign for a string? So that's the old way of doing a string literal. And it looks a little bit like this. So you'd put an @ sign before your quote start, and that makes it a literal string. And if you want to have quotes inside of it, you can. You just do double quotes it's double quotes, I should say, which is a little confusing, but it's written like that. And you can kind of split it up. But they have now added a new version, and this one's actually pretty nice. You now triple double quote, not confusing at all. And this lets you create these multi-line string literals. It can keep track of your indentation, and you'll notice that I have some quotes in there. And you might be wondering, why would I want this kind of thing? Well, it's specifically if you're going to do quotes. And everybody in here is now wondering, Brendan, I don't put quotes in strings like that in my code. I'm like, oh, you've never written like JSON in your code and it had quotes? Because this is where I actually see it coming up. I see people writing code where it's like, oh, we needed this JavaScript in here, and so we're just going to put this JSON object. And you can't tell here, but if you're in Visual Studio or VS Code or something like that, when it gets to this literal, it's actually going to syntax highlight the JSON inside of your string literal even. So that's a halfway decent way of writing that. Has anybody here had to write JSON inside of a string in C# before? Yeah, I've had to. It's not this nice. This is way better. Okay. Now, one of my favorite things that came to C#, this actually showed up, I don't know, 6 years ago, 8 years ago, something like that, I forget, is pattern matching. And every new version since seems like it has made some additional improvement to pattern matching. I love pattern matching. It's great. So I'm going to explain pattern matching because this tends to be something that confuses people a little bit in exactly how it works. So I'm going to use a child's toy. So has anyone seen one of these before where you take the little peg and you try to insert it through the hole and you got to get the right shape? Some people have seen this? Good. Anybody bad at these? No? Okay. Well, I mean, there's usually ways to cheat at these if you're really good. But I now have a question for you. What does this do when you use one of these? Does it tell you anything? Well, the cool thing is, when you put a shape through that little hole, you now know what shape that object was. So you put the little cylinder through the circular hole, and you know it's the cylinder. But there's something more important than that. Exactly, yes, you put it through the wrong hole. But the neat part is that you have it at the end. And the funny thing is that people are jokingly saying that you can sometimes put the wrong one through a different hole. And that's fine too. You can do that in pattern matching also, and I'll explain. So not only do you know the type, but you have the object. And that's why I try to explain it this way, because it has gone through and you have it, you know what it is. And that's how pattern matching works. So this is what you would have written before pattern matching. You would have said, hey, I've got my object, and then you'd want to say, if it's, I would want to cast it as a specific type, and then you check to see if it's null. Now, you don't have to do this as casting and check if it's null. You'll get a null reference exception if you don't, but, but this is how you'd do it, or you'd get an invalid cast. When you do this, you're going to end up with the object rectangle, in this case, the object rectangle, and you're going to use it. But if you used pattern matching, instead of doing that null check, you can just say, hey, if my object is a rectangle, and here's the important part, store it in the variable rec. So the end of that line there, the last piece, is the most important part. It's not that you just know the type. You could do that before. Now it's actually going to store it, if you want, in that object. So rec is a newly created variable. If you just look at the end, you'll see that that's a variable declaration. And you can immediately start using it with the properties that are on a rectangle. Because obviously, if you had a circle, length and width wouldn't have made sense. Okay. You can obviously get other things here. There's a couple of things you can check for. You can check constant values. So that's what null is. Null is actually a constant in C#. You could check it against like a number or some other constant value. You can check to see if it is a specific type, like rectangle. You can check alternate types. You could check if it's an interface. And so the interface style is one of those, you know, I don't know exactly what the object is I sent through here. You could also send a square through as a rectangle, for example. And there's some other little bits like that. And so for anybody that's now wondering, wait, if I can send a square through and as a rectangle, what if I were using this in a switch statement? And the answer is, when they put this out, they made changes to the switch statement. So when you do a pattern matching switch statement, it doesn't work like the classic constant time switch statement. They're checking in order. So be sure that it actually works. In addition to this, they have made other changes to this. So this is not a complete list. We'll talk about those in a minute, but this is what they originally put in when they added pattern matching. So now I want to talk about tuple patterns. Now I'm going to get to tuples in a little bit, talking about how they work and what they do in C#, but I wanted to talk about this here because I was talking about pattern matching. So one of the features that they added fairly recently, this is like 4 years ago-ish, is tuple patterns. So before I was checking things like, is it this type? But now you can check, if you had a tuple, is it a tuple with these values? And you could check and see, did my object have this sequence of values? Additionally, they added property patterns. So you could start saying things like, did my object have properties of this name with these values? And it doesn't have to be the same type even. So I could check to see, does my object have a width? And you're like, oh, I could see a triangle having a width, or a square, or a rectangle. Like, I don't know which one it is, but it's got it. And so you can kind of get away with a little bit of that. Additionally, they added in nested property patterns, and this one's a lot more recent. Nested property patterns are, you want to check a nested object's properties. So in this case, if you wanted to check and see if your object has an address property that has a state property on it, and before C#10, you had to basically create the nested object, whereas now they let you just say parent property, child property. And it's a lot easier to do. So hopefully you're in C#10 and can use this, because that's a pretty decent way to see, does my object have this property? And now, in the most recent version of C# have added list patterns. So if you're on .NET 7, you now have list patterns, which let you do nice things like this to check and see, does my sequence contain this exact sequence of values? Now, I have written this with a use case where we did a specific value, but it doesn't have to be. You can put in other placeholders, leave it empty, other things like that. So in this case, we've got the combination to my luggage, which is 1, 2, 3, 4, 5. It's very secure. I mentioned these before, and I do want to talk about them because they are super nice. We have tuples or tuples, whichever you like to say in C# now. Originally, they were those terrible ones that I mentioned at the beginning, but they are not anymore. Now the tuples are actually nice, and they can be constructed by just creating parentheses and putting the values in there. When you want to deconstruct them, all you have to do is essentially assign, you create what looks like a declaration and just assign them into that. So in this case, my safe parsing method is returning back a tuple that gets split into two variables, number and success. More recently, they added in the ability to do you can do the deconstruction and the construction in the same line like this. I don't recommend doing this. Your team's going to get mad at you, but you can create the object and assign it here. So if you really hate having 3 variables get assigned right one after the other because you hate lines of code and someone told you that you needed to reduce the number, look, we can remove lines of code. Way simpler, easier to read. You're welcome. Your team definitely won't. Please don't tell your team that I told you to do this. They will come find me. Okay, so one of the last things that I want to make sure we cover is record types. So record types in C# are fantastic new objects. So this would be instead of using a class, you'd use a record type. Record types allow you to create an object like that. Done. There are other ways to declare it, but this is the way that you declare it using what's called a primary constructor. Now, originally, when they were planning on putting this in the language, it was back in like C#6, something like that. They were planning on putting in the default constructors, and they didn't do it, and then they didn't do it, and then eventually they gave us tuples, and I was like, okay, fine, that gives us default constructors. I'm happy. I had been waiting for this, and it is here. So to shortly explain, if you are using a class, this is one of the best things about tuples, by the way, and you have 2 objects that have the same values. They are not equal unless you wrote a method that says how to compare your 2 objects. If you have 2 pointers to the same object, then by default it is going to say that they are equal. If you have 2 record types, not classes, that have the same values, by default, record types are going to treat this as equal because they implemented equality based on property values for record types, which is one of the nice features that you just get out of the box. They also have nice toStrings and a handful of other features. You might be wondering, why would I want a record type? Well, for the most part, I tell people if you're going to be creating simple objects that just need to transfer, so if you're doing view models, data models that get returned from APIs, different things like that, record types are fantastic with that because they don't have a lot of logic and they're basically just objects you create and use and consume. Super easy, really good for that kind of stuff. I mentioned that you can do it with the constructor or without, so you can do it both ways. And I mentioned that it's got a toString. Now the neat thing about tuples is that you can create new instances from existing records. And you might be now wondering, well, what do I do with it? Yes, exactly. What? No, not what, with. So there's, of course, my who's on first joke to tell you that they've also got this concept called with. And this is one reason why records can be super useful, even in like unit tests and things like that, is that you can create an instance of a record type, like I do up there on the top, and then you can say, hey, use that object with this change, and it will create a new instance that changed whatever value you said to change, which is super nice and lets you do that stuff. Init-only setters. These are kind of cool chains that got added to C# that I'll mention. As we run short on time, I'm going to cut a couple of things here. So essentially now you can say this object gets created at initialization time, but then is not edited after that. So for properties, you can do this, and it lets you create them through the object initializer or in the constructor, but not other times. I mentioned declaring, I should say constructing and deconstructing a tuple in the same line, but this is slightly different. I want to mention that so that people don't think I'm talking about that. Declaring and assigning in a deconstruction. So before C#10, if you were deconstructing a tuple, you had to either be declaring new objects, that's the top, or assigning into existing objects, that's the bottom example. Now, you could assign one and declare the other. So now you can kind of split that up, and you don't have to have all the objects created in advance. So if you've got a variable that already exists, but one of them is new, now you can do that. C#10 and forward. One of the other things that got added into this is the implicit constructors. You've probably seen this in a couple of my examples before. Are people here fans of var in C#, generally? Okay, I kind of like var, but I like this better. And the reason why is I like to know what the type is, and I like the consistency. So the great thing about var was I didn't have to repeat the value twice. But now if I'm declaring it, I'd put in the type first, and then just say new. And the weird part is, this is actually shorter than var in most cases, because I'm now writing the type one time on the line. If I used a constructor before, I had to write the name in there before, but now I don't even have the word var, because I've essentially moved the word, in this case, session, from the right to the left. Okay, file scope types. Oh, I should mention this. C#11 is now getting types. You can declare a class, a struct, a record as existing within the scope of that class, or that file, I should say. So it's not nested inside of another class. It is inside that file. That C# file has that type. And it's not available in the rest of your assembly. It's not available in your project. That's where it is. So super nice. And as I said, you can do it with interfaces. You can do it with records. And you go, what would I need this for? And usually the instance that comes up is you're replacing an enum or a tuple that you had or something like that. So if you had some internal object that's only used there, this is the case to use it. One other feature that I wanted to make sure I mentioned, they added native versions of the int pointer and uint pointer aliases. They added aliases for these, which is great. And you're sitting here wondering, who wanted that? And the answer is me. I use that in some of my code. I wanted that. None of you will use this, but I am happy about it. So they have made it so that instead of having to write that, I get this nice short nint. Yeah, it's great. Can you tell I'm excited about it? I'm going to remove like two characters per line and stuff. That's super nice. It's actually, it doesn't really matter. But again, who's it in there? I don't know. Me, the team. All right, so let's talk about C#12, which is the next version coming out. I got a couple of minutes. Maybe. So there are previews out. You can grab and try some of this code. You can download a new version of Visual Studio. You can grab a new version of .NET, and you can try some of this stuff. I say possibly coming because I have definitely demoed stuff that was coming in future versions of C# before that never came out or changed. So any of this could be here, who knows? All right, so primary constructors. I talked about primary constructors as the way that you declared a record type. Remember, I had that single line and all I did was define the constructor, and that gave us an object? Well, I mentioned that they were originally doing primary constructors and all they gave us was record types, and I was happy. They're bringing it back for everything. So now you can declare a class by just writing its constructor. So if all you need is just a basic object, and for some reason it can't be a record, or you need it to be a struct or a class, congratulations, you now have it. So in C# 12, we're going to be able to get that. That will be .NET 8 when this shows up. The other one, and this is shocking that it doesn't exist already, is if you are using Lambda functions in C#, you cannot right now declare default values for your parameters. And they're adding that. I don't think it needs too much explanation, but essentially, you could write code that looks like this, where you have default values. So I declare a little lambda, and the parameter has a default value. Yay. One of the other ones that has to do with types is they're going to allow us to alias a non-named type at the top of your file. So remember how we talked about how Microsoft is great at naming and how they only used using like once or twice? Here's another way you can use a using statement. And we didn't even talk about all the ones that exist, I should mention. But in this one, you can say, hey, inside this file, if I have the type candidate, it means this tuple that I've defined here. And so you can kind of just define types like this, and it is a tuple, and it exists here, which is be different from creating a record type. This will actually be a tuple. And you can do this with anonymous types, not just tuples, but it's any non-named type. Previously, you could alias a named type to say, within my file, I want it to use this alias, but that's been in there forever. So hence it doesn't belong here. That's my mother and father's C#, not mine. I say as a guy whose parent never used C#, and I used C# back in the days of my parents' C#. I told you, everything in this thing's a lie. So there's other stuff we could talk about, but I want to make sure that we have time for questions. So let me jump up to questions and see what kind of questions people have. They might be one in the Discord. There is one. Oh, hey, someone has the same luggage combination as me. That's good. Anybody else have that luggage combination? Yes. Anybody get that joke? If you did get that joke, you're old enough to be my parents' C#. Actually, it's a lot older than my parents' C#. Seriously, questions?
I have a statement more than a question.
Yes.
Why is it caret 1 for reverse indexing?
So that's a fantastic question. I kind of sort of mentioned it. So most of us, what's that? I know, right? It should be negatives. Most languages use negatives. Oh, caret 0. You want caret 0. Okay. So there is an answer for that that I do think I actually know. And that is the reason that in C#, so I think they wanted to match the way that other languages do it. And in most languages, they use negative numbers and will frequently start at -1 being the last. And the reason why is because it's hard to tell the difference between negative and positive 0. Yeah, negative and positive 0. I think that's why they dodge it. Because if you had -0 being the end, that. Yes. I mean, I agree, but I think it's the computers causing us the problem. I agree with you. It'd be nice to be 0-based going backwards, but it's tough. Like, that's what you get. So yeah, I agree. I wish it was somehow 0 at the end also, but it's weird. With carets, I think they could. I think they just wanted to match other languages. Any other questions? You can ask in Discord, which I have up, or you can raise a hand and I can maybe see you. Yeah.
So have you used the new switch expression?
Have I used the switch expressions? The answer to that is yes, I have. And I've only been shot by my team twice for having used them. So I do kind of like them. What this is talking about is in C#, there is obviously switch statements. where you go in, you put in your value, and you choose which case you want to have. With a switch expression, instead of having a full statement that is multi-line, it instead is like an expression that is going to have a return value almost, and so it just kind of like goes in. And a lot of people then also change it so that each case is written as a lambda, and as soon as you get into that syntax, obviously don't have the code up to show you, people start to say that it looks kind of tough to read. Now, I don't mind it, right? Like, I've seen it, I use it, but I've had a decent amount of backlash on that one. I don't know how other people's teams have appreciated switch expressions, so I put them as a switch statement still, but they offer both. So if you run into it, that's what's going on, and look up the syntax for it, because it's a little weird. Do you like them?
Yeah,
You do?
I switched from some method that one of my teammates made that mixed ifs and terminators.
So they used ifs and terminators and you went to an expression? Yes, that's a positive. But when you take someone's switch statement and turn it into an expression, they tend to get more upset about that. But yes, if you have a whole bunch of if statements, switch statements can get way clearer. And if you are just returning a value, the expression is actually really nice. And the cool thing about using the expression is if you did a method-bodied, my brain's not working here for a second. If you lambdaed your method, so you did an expression-bodied member, so an expression-bodied function, for example, in this case, you would end up with an expression as the entire body. So you'd be like method name, and then an expression as the implementation, and that's your switch. And there's no lines of code in there. So you can do those things, and they're neat. And that's usually what makes people mad at us when we do that. So I know from experience. Yeah, question? Yes, yes. So in the literals, they added in underscores. I cut that slide a handful of years ago out of this presentation because it gets back to old enough versions. But if you have large numbers, let's say you've got numbers in the millions, you could, instead of your commas or decimal places, depending on your culture, you can put in an underscore at those points to delineate the thousands, for example. And it works not just with base 10 numbers like we're used to, it also works in binary. So a lot of times in that case, I'll separate either at bytes or half bytes for being able to actually read it. And if you've ever seen a binary number written as a literal inside of C#, it's going to be 0B, it's going to be like 0B and then the number. And I also find that it's nice to be able to put an underscore right after the B. So it's a little bit clearer when does the number start and when does the fact that I'm saying it's binary come in. Does that make sense? So I really like that ability, which funny enough, the leading underscore was not allowed in the first version of that when they added those in. So that was actually one version later when they were like, oh, it'd be nice to be able to lead with the underscore. It works in hex also. So if you're defining like a color in hex, you could do, two hex values, underscore 2 hex values, underscore 2 hex values, right? And then that's also breaking by the byte. So super, super nice feature. I also didn't mention underscores being used as discards in C#, which is another useful one. Essentially, instead of assigning a value into something, you can put an underscore in there, and it will just throw away the value for the garbage collector to get. It'll be like, yeah, I don't want that, and you can just put in an underscore. Any other questions, comments?
Are you going to post your slide deck?
I can post the slide deck somewhere, though it comes with a caveat. If I do, I have to warn you that while I am allowed to use all the various cartoon characters in there, I don't have like publication rights, so don't like share them beyond that. So. Any other questions? I will probably toss them in the Discord, by the way, in the channel for this. Yeah?
What do you think about the native improvements with the numerics and all the kind of bare metal type of SIMD and all that, all those improvements?
So this question is jumping into all the various changes that they've made to native types in C#, and I've lumped that into the category of this feels more like stuff that you're making for yourself rather than the rest of us. It's similar to like all of the changes that they did with like ref structs and things like that. And it's like, hey, we made ref structs and read-only ref structs and all these other things. It's like, you're doing that for you, more than like, I don't use them very often. Do you? Maybe you run into it. So, meh. Any other questions? If not, and I will still be here standing around for a couple of minutes before the movie if people want to talk to me. So either way, thank you everyone for coming. Yeah.